So we're gonna continue with 8.06 resistance. First of all, today we're gonna talk about resistance. As you can see in your book, page 182. Okay? So, what is resistance? For example, I have normal circuit, I have the cell, then I have the lamp, and it's going back with the connecting wires to the battery. So we say the connecting wires, they have what? Resistance. But it's low if the connecting wire is copper. Now what if the connecting wire is from nichrome? Actually what will happen that you need much more power to touch up this lamp. Why? The thing is because the nichrome, it have much more resistance than copper. What does that mean? That means I need more power. So when I use connecting wires like copper that have low resistance, I need less voltage than the nichrome because the nichrome is have more resistance. So how I can calculate the resistance? The resistance is given by ohm, okay? It's given by ohm, and it's the Greek letter for omega, and it's the potential difference, the voltage, on the current in ampere. So for example, I have a cell or circuit with 6 volt and that have current 3 ampere. What is the resistance for this circuit or for this connecting wire? So as we say, it's volt on ampere. So the volt is what? Volt on ampere. The volt is 6, that's a coil. Volt is 6 on 3. That means I have resistance on 2 ohm. Okay? How I can find the resistance, how I can find the current, how I can find the voltage, simple, use this parameter. If you want the voltage, just cover it and you have to multiply I on R, the current and resistance. If I want the resistance just like now, I cover it, I divide voltage on the current. If I want the current, I divide the voltage on the resistance. Okay? So this you can use this way for 3 equations from this. Okay? So some factors affecting the resistance. What affect my resistance? First of all, the length. Like if you double the length, it's double the resistance. If I have 1 meter of connecting wire, for example, as a cover, if it's double length, that means it's what? It's double resistance. Okay? Second of all, cross-sectional area. So when I have halving the end of a normal wire, so when it's the half of the end area, it takes actually more resistance. So the thinner the wire is, the more resistance it is. Okay? Let me also wave. Material, like we say, if it's nichrome wire, what? It's more resistant than copper. So it's very important what is the connecting wire is made of. Okay? Temperature. For metal conductors, when the resistance is bigger, when they have more temperature, the resistance is what is higher. But for the semiconductors, when I have more temperature, the resistance is going low. You can see the figure in page 182. You can see here the resistance goes from down to up. Short, thick copper wire, long, thick copper wire. That means the long, thick copper wire is more resistance than the short, thick copper wire. The thin, long copper wire, it's more resistant from the first and the second. And long, thin nichrome wire. That means it's more resistant from all these three. Continue with the effect. The heating effect. How we can use this resistance as a heating? So the heating effect, the electrons lose energy and the atoms gain it. So when there's resistance, the electron, what happened to it? It actually loses energy, and this energy goes to the atoms and make it more vibrate. That means more temperature. Okay? So actually this is how we heat. This is how we use the hair dryer. This is how we use the toaster or the warmer or any heat or the oven, etc. So usually they are making this filament or this wire are made, or it's made from nichrome. Why nichrome? It have what we say very high resistance. That means more electrons are losing power, more vibrating for the atoms. That means they're gaining more weight. And the small torch lamp usually is made from tungsten. Why? Because it have high. As usually you see it's so thin. That means more resistance, as you see inside the lamp, and it have what high melting point, so the metal won't melt easily. Okay? Like we said, this here examples like the hair dryer, the toaster, the oven, etc. The electrical one, of course. Move along for resistance components. First of all, we keep the volt and the ampere. What we use this resistance. So the main use is for keeping the voltage and the current for certain components in complicated circuits, like for example TVs, radios, computers. So you will see it's full of resistance. Why? So they can manage that not more voltage or not more current coming to this component. Okay? So the resistance they have very different value. It starts like from 1 ohm until 1000 ohm, and it's 1 kilo ohm, like we see here. 1 kilo ohm, that means 1000 ohm. And 1 mega ohm, that means 1 million ohm. Okay? Until we have many mega ohms, like many millions of ohms. Then we go to variable resistor. Sorry. Let me draw this for you so we understand how this variable resistor is working. That's enough. So, for example, we have here cell. I have here lightweight lamp. Now, imagine you have a long bar, and around this bar there is what? There's a wire that is connecting. Okay? Let me listen. Okay. So here is the stand here that define where you are. If you are here at the beginning, okay? So what is the variable resistance? What is the goal of it? It's give us more than one value for one resistance. So it's change the value for this resistance. So when we move this, for example, till here, what will happen? What will happen is what? The length of the wire is what? It will get longer. And as we say here, more, or the fixed one here, more length, that means what? More resistance, exactly. So more I push it, that means the length is getting more. Okay? So more length, what does that mean? That means more resistance. So we change this up and down, less resistance and more resistance. What will happen to us? It's playing with volt. So when I play with ohm, what we change? We change the volt. Like we see, if we want the volt, it's the current multiplied the resistance. So if I will change it, what will happen to this lamp? It will go, the light will go even more brighter, or it will go what? Just a small light. Light is going up and down, like your brightness in your mobile phone. It's true that you put your brightness going down, it is giving an electric signal that's turned for the resistor, the variable resistor, that change up and down, the power is going to the screen, to light your screen. Then we go to the thermistors. Thermistors are giving a high resistance when they are cold, but they're giving a much lower resistance when they are warm. Okay? And there is a light dependent resistors, and they call them LDR. And this is very interesting resistor because in the dark it has very high resistance, and when it gets light it has much lower resistance. So when they use it, usually they use it in automatically light in the parks or in the streets. So when it's daylight, the street light will turn off, okay? Or in the parks or wherever. Or when it's dark, what will happen? The LDR will make the current pass and will turn off the light, okay? So it's automatic procedure, so you don't need to turn off and turn on each day for the whole park or for the whole streets you live in. We move into the dials. The dials, they depend on the direction of the current. So in one direction they have very, very high resistance, and the other direction they have very low resistance. And usually they used in electronic circuits most of all. How we say, you can see the examples. Or let me draw it for you to be sure. So this symbol is for the normal resistor. This symbol is for the variable resistor. This symbol is for thermistor. This symbol is for the LDR, that means like light coming there. And this symbol, as you're gonna see a lot later, it's for the diode. Okay? So this is the ending for the videos. Please, if you have any question, you can ask, and we'll continue later with 8.07. But now this we say 8.04 to 8.05 and 8.06 from page 178 until the page 183. That's all for this video. Thank you for listening. Take care of yourself. Don't forget to wear your mask and wash your hands. Stay safe.